Hello Internet. Today's project is this year's annual Christmas ornament. The project started out as a download of a DXF file from SD. The DXF file was then inserted into a sketch in Fusion 360. And here is the result of the model that was created in Fusion. In the Fusion sketch, some features were added. One is the lettering around the rim of the ornament, and another is some traces that are lightly shown here in blue to represent folds in the bow and the round knot in the middle of the bow. The sketch was extruded a 1/4 of an inch to represent a 1/4 inch Baltic ply that the project was to be cut from. Tool paths were then made in Fusion. The first group of 8 paths, listed here, were to be cut using a 1/8 inch V bit, 20-degree included angle, also known as a 10-degree side angle. Here is a picture of that bit. That set of tool paths was then followed by 3 tool paths, which used a 1.5 millimeter end mill to create pockets and contours. And here's a picture of that bit. The V-bit engraving tool was used to make these 8 tool paths. The first is an engraving pass for the lettering around the rim, and that is followed by a duplication of that path to do the same path engraving again, which I found improves the outcome of the project. Next, a tracing path traces this one light blue line, and the 4th path is a repeat of that tracing. The next path is the tracing for the folds on the bow, and a repeat of that tracing. Finally, an engraving pass for the outline of all of the intricate features of the ornament, which was then repeated. I found that repeating the engraving passes tended to clean up a lot of artifacts that a single engraving missed. And those 8 paths constitute the first group of tool paths that were saved in what I called path 1 here, which all used the 20-degree V-bit. The last 3 paths were done with the 1.5 millimeter end mill. First, pocketing all of the open spaces in the ornament. That was followed by 2 contours. The first contour is outlining the this area in the center of the ornament. That could have been done with a pocketing strategy, but because of the size of the area and the small size of the end mill, that would have taken a long time. So instead of a pocketing strategy, I just contoured and left tabs to hold this piece of material in place while the project was being cut. And the final pass is the contour around the outside of the ornament, completing the project. Now let's go to the machine and make some ornaments. This is a 1/2 inch melamine board which has been clamped to the CNC table, which will be used to support the project boards. Here the project board is being screwed to the melamine board. The project board is a 1/4 inch Baltic birch plywood. I found that it is very important for engraving projects to be very flat with regard to the travel of the engraving bit. Here you can see that there's some variation, as much as almost 9/1000ths of a dip in the middle of the project board. This dip was corrected by placing some shims in the form of newspaper to shim up that low spot in the board. And here is a verification of the correcting action of the newspaper shim. Now we're within 3 or 4 thousandths across the entire board, generally even closer than that. Here we're showing on the Mach 3 screen that 8 replications of the ornament project can be fit on the board. And now we're starting the engraving bit pass using the 20-degree V-bit. All 8 of the engraving pass will be cut on the 8 different replications. We're starting out with the lettering pass. All the V-bit pass use a feed rate of 30 inches per minute and a spindle speed of 15,000 RPM. And here's that first tracing path. Now we're tracing the folds in the bow. Here in replications 1, 2, and 3, you can see the ornament with just the V-bit pass completed. Now in the 4th replication, we're working on the engraving pass of that large central portion of the ornament. At this point, the V-bit paths for all 8 replications have been completed, and we're starting the 1.5 millimeter end mill passes. The first passes are the pockets. All the end mill paths use a feed rate of 40 inches per minute and a spindle speed of 18,000 RPM. Now we're starting the contour pass of that large central area. And now we start the final contour of the outline of the ornament. And this process is repeated 8 times. The ornaments are removed from the 1/4 inch plywood board, and they need to have some sanding done to clean up the tabs. The inexpensive 1.5 millimeter end mills leave quite a bit of fuzz. The fuzz is removed using emery boards. Here's a view of the project after fuzz removal. All the dust is removed with a shot of compressed air. Three coats of deft lacquer were sprayed on. And here are some of the finished ornaments. Thanks for watching, and Merry Christmas!